In this video, we're going to learn how to do implicit differentiation. And basically what that is taking the derivative of an equation with more than one variable in it. So in order to do this, we have to have the equation in implicit form, which basically just means that both variables are on the same side of the equal sign. And then once both your variables are on the same side of the equal sign, all you have to do then is just take the derivative like you would with the normal derivative rules. So let's start with an example. So let's just say we have x cubed. So in order to take the derivative of this, we would just use our power rule and go 3x squared. Now, implicit differentiation would be something that you would have to use to take the derivative of y cubed. Now, in order to do this, it's going to be 3y squared. The same basic power rule applies, but we're taking the derivative of y with respect to x. So it's important to include that in the equation as you're taking the derivative when there's a y in there. So another example would be xy. When there's two terms multiplied together, the same thing is going to apply. We're going to use the product rule just like we would in a normal derivative. So we're going to take the derivative of the first, which is 1, times the second, which is y, plus the derivative of the second times the first, so it's going to be x, and then the derivative of y is just dy dx. So that would be your derivative of xy. So let's just write out the basic guideline so we can understand kind of what our steps are. So first, you're going to differentiate both sides of the equation with respect to x. With respect to x. Now once we've done that, we're going to move all the terms with dy dx in it, because remember we're going to include that whenever we have the derivative of y being taken, we're going to move it to the left side of the equal sign and move all the other terms to the right side. Then we're going to factor out that dy dx. I'll show you what I mean in just a minute. And then finally we're going to solve for dy dx. And now this is our ultimate goal, and this is what we're trying to achieve when we talk about taking implicit differentiation, is solving for this. So we're going to look at a little bit of harder example that you might see on the AP Calculus exam, which is what I think is kind of the way to look at these problems. So let's just say we have xy squared plus 3x plus 2y cubed equals 7. And the problem maybe on the AP exam is asking us to take the derivative with respect to x of this equation. So we're just going to look at it one by one. So we're going to start, remember our guidelines. Let's pull these back up. We're going to differentiate both sides with respect to x. So let's start here. Obviously we know that this is two terms multiplied together, so we're going to use our product rule. So we're going to go derivative of one times the other. So this will be 2xy dy dx, because we took the derivative of y in this, plus derivative of this one times this one, so it'll just be y squared. And we're going to leave that in parentheses. Then we're going to take the derivative of this, which is just 3. Then we're going to take the derivative of this, which we're going to use our power rule, so 6y squared, and then don't forget to put that dy dx equals 0. Now next we're going to let's get all our common terms next to each other so we can see kind of what's going on here. So 2xy dy dx, and then we're going to have that plus 6y squared dy dx. Then we still have our plus y squared and our plus 3, and that's still going to just be equal to 0. So we're going to move all the terms that don't have dy dx in them over to the right side. So let's go ahead and do that. So we've got 2xy dy dx plus 6y squared dy dx equals, so we're going to subtract over these, negative y squared minus 3. So then we're going to factor out the dy dx out of the left side of the equation. So it's going to be dy dx times 2xy plus 6y squared equals negative y squared minus 3. And then for our final step to get dy dx by itself, because remember that's our ultimate goal for implicit differentiation, we're just going to divide both sides by this stuff right here. So our final answer is going to be dy dx equals negative y squared minus 3 over 2xy plus 6y squared. And that is a big example of implicit differentiation that you might see on an AP exam. So just know how to get this dy dx by itself and know how to isolate that. And that's implicit differentiation.